Pandalus borealis. It is known as the northern shrimp or the pink shrimp. However, its most common name is food. The northern shrimp is commercially harvested more than any other type of shrimp in the North Atlantic Ocean. However, due to ocean acidification caused by global warming and the emission of greenhouse gases, this species and the commercial fisheries that specifically target it may be in danger. But what is ocean acidification? Ocean acidification is the process by which carbon dioxide from the air is absorbed by the ocean, making it more acidic and lowering the pH. However, carbon dioxide is not an areneous acid, so how does it do this? Well, when carbon dioxide is absorbed by the ocean, it bonds with water to form carbonic acid. Then one hydrogen ion from each carbonic acid breaks away and leaves hydrogen carbonate behind. In this manner, the amount of hydrogen ions increases, the pH lowers, and ocean acidification occurs. Carbon dioxide is normally circulated through the atmosphere due to the carbon cycle. However, burning fossil fuels like coal, natural gas, and oil add more of the gas into the atmosphere than should normally occur. So, how do we change this? One possible alternative is geothermal energy. Geothermal energy is energy that is collected from the heat of the earth. The way this is done is that wells are drilled into the earth, and then hot water or steam is piped to the surface. Then the hot water or steam is used to operate a turbine to generate electricity. There are three different types of geothermal energy generation plants, or GEGPs. That's an acronym I made up. It's not actually a thing. However, for the purposes of this video, we are going to call them GEGPs. Anyway, the first type of GEGP is a dry steam plant. Dry steam plants use steam piped directly from a geothermal reservoir to turn generator turbines. The most common type of GEGP is the flash steam plant. Flash steam plants take high-pressure hot water, which is piped up and then converted to steam, which is then used to drive the turbines. After that, the water is piped back into the ground. The third type of GEGP is the binary cycle power plant. In this method, hot water is piped up just like the flash steam plant. However, in this method, the heat is transferred to another liquid that becomes a gas, and then the cooler remaining water is piped back down into the ground. In addition to these three systems, geothermal energy can also be utilized in the form of heating. Geothermal heating uses a loop of pipes buried just beneath the ground called a heat exchanger. These pipes are filled with water or a water and antifreeze mixture. During winter, the ground is typically warmer than the air, so the water in the heat exchanger gains energy. Then the warmer water is pumped up to a heat pump, which warms it more, and then the heat is transferred to the normal heating system, where it is heated to a comfortable temperature. The process also works in reverse, as in the summer the ground is typically cooler than the air, so the heat exchanger helps to initially cool the water so that the AC has to do less work. Anyway, the three systems I mentioned earlier are closed-looped systems, which have very few emissions. However, there are also open-looped systems. These systems don't pump the water or steam directly back into the ground, and release some gases into the air that were trapped in the water as it was piped up. The main gas that is released is hydrogen sulfide. However, carbon dioxide, ammonia, methane, and boron are common pollutants released by open-looped systems, and some GEGPs have to deal with trace amounts of mercury emissions. The main problem with this is the release of hydrogen sulfide into the atmosphere. In air, hydrogen sulfide becomes sulfur dioxide. This forms small acidic particulates that can be absorbed by the bloodstream and can cause heart and lung disease. Sulfur dioxide also causes acid rain, which damages crops, forests, soils, and acidifies lakes and streams. Despite this, sulfur dioxide emissions from GEGPs are approximately 30 times lower per megawatt hour than from coal plants, which are the U.S.'s main source of sulfur dioxide emissions. GEPs also take up large amounts of land. The amount of land that GEGPs take up is dependent on several variables, including, but not limited to, the size of the resource reservoir, amount of power capacity, the type of energy conservation system, the type of cooling system, the arrangement of wells and piping systems, and the substation and auxiliary buildings needed. To give an example of the scale of such GEGPs, the Geysers is the largest geothermal energy plant in the world and covers approximately 78 square kilometers while producing 1,517 megawatts, which is approximately 13 acres per megawatt. Big word. One major problem with GEGPs is land subsidences. A land subsidence is a phenomenon in which the land surface that the GEGP is built on sinks because of the removal of water from the reservoir. Most GEGPs re-inject the used water back into the ground to help prevent this. Also, GEGPs tend to be located on areas that have an increased risk of earthquakes and can also lead to an increased earthquake frequency. Despite this, GEGPs have anywhere from 0.1 to 0.2 pounds of carbon dioxide equivalent per kilowatt hour, whereas plants that make energy from natural gas have a footprint of 0.6 to 2 pounds per kilowatt hour, and coal energy production emits a carbon dioxide equivalent of 1.4 to 3.6 pounds per kilowatt hour. So, benefits of geothermal energy are that it is a renewable resource, and while it does emit dangerous gases, it emits much less than traditional energy production plants. Drawbacks of geothermal energy are that GEGPs are expensive to build, take up a large amount of land, and it is hard, especially in the case of geothermal heating, to transport energy from the site that it is collected at. Altogether, despite increased risk of earthquake, geothermal energy is a good source of electricity and is a great alternative energy source for those who live near areas that have easy access to the Earth's heat. However, in other areas, solar, wind, or hydropower are much better choices for energy depending on the location and situation. All in all, the burning of fossil fuels emits way too many greenhouse gases, and renewable energy sources, like geothermal energy, should be used instead.